Okay, so I am going to be talking about your test review and just going over a few last minute things before you take your test. So here we go. When there's a negative either inside or in front of a radical, there's going to be some sort of a flip. So we're going to have a flip. Now with cube roots, it's harder to tell which way they're flipping. So for these, you don't have to be as specific, so it doesn't matter if you're flipping over the x-axis or the y-axis because it's tricky to tell. But definitely for square roots, you should tell me which direction it's flipping. So let's do number 1 first. We're taking a cube root, so we want our magical pretty numbers, and they are -8, -1, 0, 1, and 8. So that's my goal to get inside of the radical. Okay, so we're going to make a table of values. So how do I go, when I have this guy, which is basically -1 times x, how do I get to -8? Well, I'd have to multiply by a +8. So +8 times -1 is -8, and the cube root of -8 will be -2, and then this will be -1, 0, 1, 2. So -2 plus 3 is 1. Okay. Then to get a -1 in here, I would have to multiply by a +1. -1 times +1 is -1. And the cube root of -1 is -1. And -1 plus 3 is 2. Sorry. And then to get 0 in here, I'd have to multiply anything by 0. So the cube root of 0 is 0, and 0 plus 3 is 3. Then I want to get a +1, so that would mean I would have to multiply by a -1. And that will give me the cube root of a +1, which will be 1 plus 3, which is 4. And then I want to get a +8, so that means that this guy would have to be a -8. -8 times -1 is +8, and the cube root of +8 is 2, and 2 plus 3 is 5. So then we graph. We have a dot at 8, 1, and then 1, 2. And then 0, 3, -1, 4, and -8, 5. So there is my cube root graphed. So fancy. And again, it's hard to tell which direction it flipped, but we also shifted up 3 places, because the extra number is not inside of my radical. So like on this one, I'm going to shift right 2 because it's opposite of the sign. And this one would shift left 6. But this guy doesn't, again, have another number inside of my radical. Now, this is a square root, so we're going to pick our pretty numbers with our square roots. So remember, we can't take square roots of negative numbers, so our pretty numbers are 0, 1, 4, 9, 16. Okay. So the square root of 0 is 0. And since there's a negative in front, that means it's going to be -0, which doesn't make any difference. But since this is just a regular radical, we can just use these numbers, 0, 1, 4, 9, and 16, all of our pretty numbers, because those are going to give us nice whole answers. Sorry, again, the square root of 0 is 0, and then that's technically a -0, and -0 minus 6 is -6. The square root of 1 is 1, which will turn out to be a -1 minus 6, which is a -7. The square root of 4 is 2, so that makes it a -2 minus 6 is -8. Notice we have a pattern going on. You should have a pattern in each of your tables. Okay. And then we have the square root of 9, which is -3, and -3 minus 6 is -9. And the square root of 16 is will be 4, and then it's a -4 minus 6 is -10. Okay, and if I could fit more on here, I would, but my graph is only so big. So we have a dot at 0, -6, 1, -7, 2, oh, just kidding, 4, -8, sorry, and 9, -9, and I can't fit 16. So here's my graph, like that. Okay, now the parent function of a square root looks like this. So to go from this to this, it flips this way. So to flip this way is a flip over the x-axis. So a flip over x-axis. Okay, a flip over the y-axis would look like this. It would go that way. Okay, because then it's flipping over the y-axis because it normally goes this way. So this would be a flip over this axis because it would go like that, and that would be the y-axis. This is a flip against or over, across, whatever you want to say, the x-axis. So that's how you do those. On the back side, so we have some piecewise functions that we need to graph. So remember, these are our walls. So we have one wall at positive 2. So we're just going to draw that guy there. Okay, and then this is negative 6. So negative 6 is here, and I need a closed dot at positive 2 because there's a line under it. So a closed dot, and then it'll go that way because I want this function for all values less than 2. Okay, and now we need to go this direction for all my numbers greater than 2. So I'm just going to pick my pretty numbers and then graph what I can. So my pretty numbers for square roots are 0, 1, 4, 9, and 16. Okay, now I can't just put these numbers down here because I'm getting subtracted by 4. So what number minus 4 is 0? 4. 4 minus 4 is 0. And the square root of 0 is 0. What minus 4 is 1? Well, 5. 5 minus 4 is 1, and the square root of 1 is 1. What minus 4 is 4? 8 minus 4 is 4, and the square root of 4 is 2. What minus 9 is 4? Wait, no. What minus 4 is 9? There you go. 13 minus 4 is 9. And then the square root of 9 is 3. We're not going to be able to go much further. That's how you do it. Okay, so I want and I can't go up anymore because we can't take the square root of negative numbers. I want an open dot at 2. So at 2, and here's the thing. These don't go that low. So I'm going to skip it. So there's a gap, which is fine. My first dot will be at 4, 0, which is here. So I don't have an open dot here because my graph cannot go negatively. And then I have a dot at 5, 1, at 8, 2, and that's all I can graph. So there's a gap, and there's my curvy. But if it would have been on the line, it would have had to been an open dot. Okay, let's do number 7. So this one, again, we have walls at negative 2 and 4. So we're going to draw a wall at negative 2 and then a wall at 4. I want a closed dot at 6, positive 6, but all numbers that are less than negative 2, so that way. And I also want an open dot at 4 for all the numbers greater than 6. So now we just got to deal with the business in the middle. And this would be the absolute value of x minus 2. So for that, we're just going to pick numbers that are in the middle, and I'm going to especially pick the walls. So we have our x and our y, negative 2, 0, 2, and 4. That's good enough. And if we need to fix it, we'll fix it. Okay, so the absolute value of negative 2 is 2, because negative 2 is 2 spaces from 0, and 2 minus 2 is 0. Okay, 0. The absolute value of 0 is 0, because 0 is 0 spaces from 0, so then we have minus 2. Okay, 2. The absolute value of 2 is 2, because 2 is 2 spaces from 0, and 2 minus 2 is 0. And then the absolute value of 4 is 4, because 4 is 4 spaces from 0, and 4 minus 2 is 2. So then we graph. We have an open dot that we have to put on this line at negative 2, 0. So that's here. So here's our open dot. And then we're going to have a dot at 0, negative 2, 2, 0, and 4, 2. And it looks like that will give us our V, so we don't have to do anything else. So that's what that looks like. And it's closed dot because of this line, so just make sure that that's closed. Okay, and then the last one. Number 9. So draw our walls at -4 and 1. So -4 and 1. Okay. All right, so square roots. Again, we want to make our pretty numbers. So our pretty numbers with our square roots are 0, 1, 4, 9, and 16. So what times -3 is 0? 0 times -3 is 0. And the square root of 0 is 0. What times -3 is 1? Oh, we're getting into decimals. 1/3 times -3. Well, no, -1/3. 1/3, -1/3 times -3 is 1, and the square root of 1 is 1. What times -3 will be 4? Well, again, you can do the same thing and put it on the top. So you could do -4 third. No, it would have to be -8 thirds. Let's see. Let's see if that works. -8 thirds. This one's not very nice. Times 4. Oh no, I done messed it up. Okay. Oh, I don't love this one. I might just have you use decimals, because these are all going to be decimals anyways. It's hard to get our pretty numbers. We have to think backwards. The first one is good though, because -3 times... Oh, I messed up that other one. Never mind. Okay, -3 times 1/3. I am so sorry. Oop. -1/3. Ah! Good golly. Struggling. Is 1. Okay, now let's try this again. I messed it up. It shouldn't have been 4. It should have been times 3. -3. Oh, my bad. Should be just be 4 thirds then. Because the 3's cancel. So 4 thirds times -3 is 4, and the square root of 4 is 2. And then it would be the same thing with the 9. -9 thirds. And the square root of 9 is 3. The reason that this works is because when you multiply a whole number, like -3, times something, and you want to get rid of this 3 that's in front of it, you just put it down below, and these will cross cancel, and whatever you have left on the top will be your answer. So that's why I changed all of these to those fractiony ones. Okay, anyways, now we have a dot at 0, 0, and then -1/3, 1. Okay, -4 thirds, which is -1.3. That's not going to help us. -9 divided by 3 is 3. Nope, that's still not going to help us. Okay. These numbers are going to get closer to 0. Oh, wait. Okay, so none of these are in this section. They're all in this section right here. So we technically have to keep going. So let's keep going. -16 over 3. -16 divided by 3 is, -5.3, which we can actually graph that. And then that would be the square root of 16, and the square root of 16 is 4. So we have -5 1/3, and then up 1, 2, 3, 4. And then we could do the next one, 25, because that'll be 5. So that will be -25 thirds, which is -25 divided by 3, -8.3, so -8. Oh man, it is over. And then it will be up 5, like here. Okay, anyways, it's a closed dot, so something like this. That's not very pretty. Okay, whatever. It's done. All right, now, this guy in the middle is an exponential, so we are just going to make a table of values, x, y. we're going to include our walls. So we have -4, -2, 0, and 1. Oh, sorry. And then we just plug it in. So we have 3 to the -4, which is 0.01. Oh, did I press 1? Oops. Golly. Hold on. I messed that one up already. 3 to the -4. And then we're going to have to add 1 to that. 1.01. I forgot about that guy. Sorry, my bad. Okay, let's do it again. I just wanted to make sure. We're good. Okay. Oh, good golly. Okay, 3 to the -2 plus 1 is 1.11. Anything to the 0 is 1, and 1 plus 1 is 2, and 3 to the 1 is 3, plus 1 is 4. Okay, so we have open dots on -4 and just a little bit above. So an open dot there. And then -2, 1.1, so there, 0, 2. And then 1, 4 is going to be a closed dot. So there's the middle-y part. Exponential curve. And then the last one, this is a linear equation. Again, you can make a table of values or you can just graph. Now I don't want the middle section, I just want this side, so I'm going to write it in pencil. We start at +2, and then our slope is -1 over 1, and this will have to be an open dot. And then we'll keep going, -1 over 1, -1 over 1, like this, all the way up. All right, and there's the last one. Okay, I get that this part in the beginning was really weird, but if you are multiplying by a number, so there's just so much going on. If you are multiplying by a number, -3 times something, and we're trying to get like a big number like 16, the easiest thing to do is to put this number in the top part of your fraction and this number in the bottom part of your fraction. And then you will get 16 every single time. And it works for all the things. So like if it's -5 and we're trying to get 16, so we would do -5 times 16 over -5. I'll show you. -5 times 16 over -5. And then we get our 16 because our fraction rules say that the -5s will cancel, leaving our number. So we can always figure out what we're multiplying by changing this number to the top part of our fraction and this number to the bottom part. And then in order to figure out how to graph that, we would have to do 16 divided by -5, so we know, oh, well, that's at -3.2, so we knew where to put our dot. So that's why I divided our fractions to get decimals. If you have any questions, let me know. Have a great day, guys. Bye.